This video is going to be a helpful hints video for the Equilibrium and Le Chatelier's Principle Lab, and I want to show you a little bit more about how the simulation works and what happens when we make changes, because this lab is really going to make you think about what has to be happening for these changes to occur. So when you're at this simulation, remember that this picture shows you what it looks like at equilibrium. So right now it's purple, which makes sense because you have some reactants and some products. So you have blue and red reactants and products mixed together makes purple. So you have a blue solution and a red solution combined in some ratio will give us this purple solution. So when we look at the lab, the first thing that we're doing in the lab is we're adding some drops of KCl. So if we click on the drops of KCl, what we notice is that it went from purple to blue. So what this picture is showing is the initial equilibrium, and then once equilibrium is re-established. So once we add KCl, this reaction shifts in a way to make the new equilibrium more blue. So when you look at the equation, if after new equilibrium is reestablished, it's blue, that means that you have more reactants. So that means that the reaction shifted to create more reactants at equilibrium. And that makes sense because KCl dissociates into K plus and Cl minus. And so if we take a look at the lab, it's asking, what color is formed, what happens at equilibrium, but then more importantly in part C, it says to justify our choice, talking about Q versus K and how Cl minus changes. So remember that KCl will dissociate into K plus and Cl minus. So when you are adding KCl to this solution, you are actually adding Cl minus. And if we think about it, if we're adding Cl minus, now we're adding more to the product, so now our ratio is off. Now we have too many products compared to reactants, so the reaction is going to shift to use up the products to make more reactants. And if we think about it in terms of Q versus K, when we make this disruption at equilibrium, we're adding more to the products. Remember that Q is products over reactants. And so if we're adding more to the products by adding this extra Cl minus from KCl, that causes Q to be greater than K. Since Q is greater than K, it needs to shift to the reactants to create more reactants and bring that ratio back up. So the pictures that you're seeing in the simulation are after there's this shift. So you're not going to see a step-by-step. This is not a reaction mechanism. You're adding Cl minus, and it's going to shift. And it's going to shift to the reactants. And so when it reestablishes equilibrium, it's more blue because now we had to create more reactants to get back to equilibrium. So we had to use up some of the red solution in order to use up the excess Cl minus. So we had to use up some of the red solution, create more of the blue solution to get back to equilibrium. So number 4 is a little bit tricky because it talks about adding AgNO3. So it says to add a few drops of aqueous silver nitrate. Now I do want to draw your attention to the note at the bottom of the website. It says silver ions react with chloride ions to form the insoluble compound silver chloride. So when I add AgNO3, I notice that it goes from this initial equilibrium of purple to a pink with a solid on the bottom, and it looks like maybe there's bubbles. It's hard to tell if these are bubbles or if this is solid, but there is a solid down here in the bottom. So those are your observations that you need to make. So if this is shifting in a way that is causing the new reestablished equilibrium to be pink, we need to think about what is happening. So when we look at this, you can answer about the color and anything else that you see, but then part C says write the net ionic equation for the chemical reaction that occurs when AgNO3 is added to a solution that contains Cl minus ions. So net ionic, That is your simplest ionic equation. You've gotten rid of all of the spectator ions. You're just showing the ions that are reacting to either form a precipitate or a liquid or a gas. So you're looking for the net ionic. Now, what we need to think about here is what adding the AgNO3 is doing, because there's no Ag plus in here, there's no NO3 minus in here. But that note at the bottom of the website was really important, because it said that the Ag plus ions react with the Cl minus ions. So we actually have this extra reaction occurring in order to use up Cl minus ions. So we have this extra reaction that's occurring, and what's happening is that Ag plus reacts with Cl minus, and so it's removing the Cl minus from this equilibrium solution. So the net ionic equation that we're thinking about is what happens when Ag plus ions and Cl minus ions combine to form solid silver chloride. That's your net ionic equation. And so what's happening when it's talking about equilibrium in this scenario is that we're thinking about a way to remove product. So this is removing product. And so since this is removing product, if we think about Q versus K, now we don't have enough product. That's decreasing the value of K. We don't have enough in the numerator. So Q is less than K. To get back to equilibrium, to reestablish equilibrium, the reaction needs to shift in a way to make more products. And so what's going to happen is that the reactants need to react. So we're using up the blue solution. We're creating more products. We're creating more of this reddish-pink solution. And so that's why we see that pink color when equilibrium is reestablished. And so the last shift that I want to look at is what happens when we dilute a solution. So it tells us to add water. So we add water, and we notice that it turns pink or red. When we add water, that means that it's shifting to the side that is pink, which are the products. So when we talk about dilutions, we need to think about why is this shifting toward the products. Dilutions have to do with your Q expression. So in the lab, it has you write the Kc expression in terms of the variables A, B, and C. So you're actually just assigning variables to the reactants and the products. So you're assigning variables to the reactants and to the products. So we have our K expression, products over reactants. You can write that out for A, B, and C. And then in part C, it says the solution in the test tube was diluted. Let's assume that the volume was increased to twice as much as the original. So if volume was increased to 2 times the original, now think about it as dividing by 2 times the liters. So instead of dividing by 1 liter, imagine now you're dividing by 2 liters. Well, what that does is that cuts the molarity in half. So all of these molarities are now going to be cut in half. When you plug those new molarities in for Q, you want to see, is that similar or different to K? And you're going to find that it should be different. Now you're dealing more with fractions here, right? So you're going to have your K expression, and then you're going to see that your Q value is a fraction of K. Well, if Q is less than K, it's going to shift toward the products. It needs to make more products to get back to equilibrium. If Q is greater than K, it's going to shift toward the reactants, because you need more reactants to reestablish equilibrium. So really this is focusing on Q versus K, and look at that fraction that's involved in Q. Remember, to be at equilibrium, Q needs to equal K. And then in the rest of this lab, you're looking at temperature and how temperature affects your shifting and K. So you can click on your Bunsen burner to add heat. So remember, adding heat or increasing temperature is like adding heat. Decreasing temperature is like removing heat. So based on the shifts, you're actually going to need to figure out if this process is exo or endothermic. So you need to think about which way it shifts and where you would expect to see heat. Should it be as a reactant or should it be as a product? So again, this was just to provide some helpful information for the lab itself. If there are still questions, as always, let me know. But hopefully this gives you some guidance as you're going through the lab.